Okay, hi, this is the review for CBA number 1, parent functions and transformations. Okay, we're going to start with number 1. Consider the function f of x below, this line that has two endpoints not included in the function. Using a dashed line, draw g of x by shifting f of x, this is f of x, 4 units left. So we just have to move 4 units left. 1, 2, 3, 4, and really you just have to move the endpoints. 1, 2, 3, 4. 4 units left. And then the whole line moves 4 units left. So now I'm just going to draw a line between the two open points. And then I'm going to label this g of x. So this one's f of x. This one is g of x. Remember, f is the one you start at. If we were talking about linear, quadratic, etc., that would be your parent function, but this isn't really a parent function, it's just a function that stops. And this is your g of x after it's transformed. So we need to write g of x in terms of f of x. So g of x equals f of x. And now we have to decide what causes it to go 4 units to the left in an equation. Is it f of x minus 4 on the outside? Is it f of x plus 4 on the outside? Is it f of x minus 4 on the inside? Or is it f of x plus 4 on the inside? Well, if you look at your vocab cards, you should have a card that says f of x minus h. And this is a horizontal translation in the opposite direction. So left would be minus, so opposite would be plus, and it's 4. So it's this one right here. Number 2. Using the rational parent function, f of x equals, well, what is the rational parent function? If you look at your parent function cards, you can see that it's 1 over x. And it says look up in parent function card, so hopefully you already got that one on your own. Write a function f of x that is rational and is shifted 3 units to the left. So we just did that up here. It would be, let's see, g of x. That's your transformation. But actually, it says write a function f of x that is rational and shifted 3 units to the left. But we're going to go ahead and use g of x to keep it consistent, because that's always our transformed function. And it would either be 1 over x, like this, 1 over x minus 3, 1 over x plus 3, 1 over x minus 3, that the whole thing on the bottom, or 1 over x plus 3. Well, we know these are vertical shifts, that f of x plus k, that's a vertical shift. You should have that on your vocab cards. And so this one isn't it. So it's one of these two. So again, it's 3 units to the left, and it's opposite on the inside, so it's this bottom one. Okay, number 3. Move the following parabola as follows. And this one gets kind of confusing because it has decimals, but just go, well, this falls halfway between. So go your half. There's your half. Now just go 6. So 1, 2, 3, 4, 5, 6. 6 and a half left. Now we're going to go reflect it over the x-axis. Well, we're down from the x-axis 1, 2, 3, 4, 5 1/4 about. So let's go up 5 1/4. 1, 2, 3, 4, 5, and a little bit. Move up 4.75 units. Well, if I'm up a quarter, if I go another 3/4, it takes me to here and go another 4. 1, 2, 3, 4. And since we reflected it over the x-axis, it turned upside down. And you just have to sketch it. You don't have to draw it. So just make it look approximately like the other one looks. Like that. So what is the equation for the new parabola? Well, this is a little bit of a tricky one. Because remember, you have to go off the parent function. So our parent function is back over here at the origin. The vertex at the origin. So always do your transformation from the origin. So let's figure out, where did we turn, or where did we shift? Well, we went over 1, 2, 3, 4. So from the origin we went left 4, and it looks like up 10. Yeah, up 10. And then it flipped over the x. So, and this is an x squared, because it's a parabola. That's our parent function. So we got to go left 4, up 10, and reflect over the x from the parent function. Don't shift it from here, all this stuff. You just did that to get where your parabola landed. Okay, so we're going to go g of x equals, well, I went over the x, so I need a negative out front, because remember, negative f of x, this was on the board the other day, that makes it reflect over the x. So negative f, what makes it go left 4? Inside the parentheses, opposite, and up 10 plus 10. And there's your equation. Except for that, I shouldn't have used f. I should have used the x squared. I forgot I was using the parent function. So it's going to be negative x plus 4 squared. That makes it the quadratic parent function. So g of x equals that right there. Next page. Number 4. The graph of f of x equals x squared plus 8 is translated to produce x minus 8 squared plus 8. Well, notice the only thing that changed from here to here is this part. And this would mean that it went, well, let's do x squared plus 8. X squared plus 8 would be right about here. And then x minus 8, that would go right 8. It would actually end up still up 8, but right 8 from the origin. So really it just moved to the right. Because remember, inside it's opposite. Graph the inequality. Step 1, get y by itself. Yay, y is already by itself. Then you just go to, I wasn't supposed to use this graph for number 4, so we're going to erase this. We need this graph for number 5. Okay, so here's my y-intercept. Remember, mx plus b. 9 is our y-intercept, so we go up here to 9. And then our slope is negative 3, 4, so it's rise over run. So we go down 3 over 1, 2, 3, 4. Do it again. 2, 3, 1, 2, 3, 4. Might as well do it again. 1, 2, 3. End up like over in here. Then you just take your line and draw your line. And I should have used a line with arrows on it. Oh, never mind. Let's undo that. There you go. And then just draw arrows on the end. to show that it keeps going forever and ever and ever and ever. Okay, now, I actually made a big boo-boo because this is a greater than sign. This is going to be a dotted line. And I think I did that in the notes when I was teaching you. I forget to look at what my line is, so I'm just going to go over it in blue to show this is actually a dotted line or dashed line because it doesn't have that equal to. So this should be a dotted line. And then you shade, well, it says y is greater, so you shade above because your y's are greater up here. And so you shade over here. And that's it. And make sure you did a dotted line. Write the equation, number 6. Write the equation of the parent function y equals the absolute value of x is translated 3 to the right and 4 down. So f of x, let's use function notation. Absolute value x minus 3, opposite inside the brackets, and then 4 down would be minus 4. So 3 to the right would be the minus 3 on the inside, and the 4 down would be negative 4 on the outside. Alright, which of the following relations is a function? And again, you got to look for non-repeating x's, because we don't want the x's to repeat. So if our x's repeat, not a function, not a function. These, the x's don't repeat. That was on the last test even. Alright, use 3 different colors or 3 different line styles to draw the graph of y equals x squared. So that's our parent function. So draw your parent function right here in the middle somewhere. Just kind of a medium-sized parabola. Let's see, same grid, sketch 1/4 x squared. So if you have a calculator, do it on your calculator. There's an online graphing calculator on Edmodo. You can go use it. Some people are saying it doesn't work, but it works fine. You gotta make sure you know how to use it. If you need help, come after school. I'll help you use it. Okay. Well, the 1/4 x squared flattens it out. You'll notice. And then the, let's see, 1/4 x squared minus 5, it flattens it out but moves it down 5. 1, 2, 3, 4, 5. So it's pretty much just that same one but moved down 5. So this one, compressed down by 1/4. Still not very good at writing with this thing. Some people are really good at writing with these tablets. Okay, so you should have written compressed down by 1/4. Hopefully you already wrote that. Not waiting for me. Let's see if I can do this better. Still can't get that Y. There you go. Alright, on the same grid sketch, so this one it says, then move down 5. Next page. Okay, on the grid, use 2 different colors or line styles. Graph 1/4 x squared. So again, let's put our parent function on there. It's kind of a medium-sized parabola. Kind of starts at the origin, down the middle. Graph 1/4 x squared. We just did that. Flattens it out some. Like about like that. And the 4x squared, guess what? It should go up like this. I should have used a different color. I'll go over that with green. Okay, describe the difference. Well, the difference is 1/4 compresses and 4 stretches it up. Compresses down 4, and this is times. That's like your, let's see, g of x equals a times f of x. Anytime you're multiplying, see your parent function right here, it's being multiplied by an a. It causes it to dilate or compress. So 4 dilates up or stretches. Okay, what is the domain for f of x? Domain is your x's, so you want your small x to your large x. Small x for f, -5. Closed circle, put a bracket. Large x, -1. Closed circle, put a bracket. This one, g, goes from 1, closed circle, put a bracket, to 5. Inequalities for these would look like this. -5 less than or equal to x less than or equal to -1. Having a little trouble with my inequality signs. Disappeared for a minute. But you're like, oh yay, I'm done. Nope, it's back. And then the other one is 1 is less than or equal to y less than or equal to 5. Number 11. If the graph of the equation y equals x squared plus 1 is translated 3 units down, what will be the equation of the new graph? Well, if I'm at x squared plus 1, so I'm at plus 1, and I go down 3, 1, 2, 3, I'll end up at -2, right here, x squared minus 2. X squared stays the same, you just go from plus 1 to down 3 to -2. G, what is the effect on the graph of the equation y equals the square root of x minus 4 when it changes to x plus 8? So again, we're 4 to the right, because remember it's the opposite direction inside. And we have to go all the way from, we always start, for both of these, we start at the origin. We start at the square root of x. F of x, that's your parent function. And it's at the origin and goes up kind of like this. This other one over here would look like this, because it would just move 4 to the right. And now we got to move from here 8 to the left. 1, 2, 3, 5, 6, 7, 8. So hopefully you can see the difference from here to here is we went left 12. Okay, that's the end of part 1. I'll do the last 2 pages on a different video.